Welcome to our tutorials for today. Today we are going to be looking at questions on differentiation. We're going to be looking at differentiation using the direct method, that is direct differentiation. Now let's look at some of these questions on the board. The question here says, find the differentiation of the following. So we have here, the first one is y equals to 6x squared minus 1. So let's look at it. We have solution. We have y is equals to 6x squared minus 1. Now, the idea of differentiation is reduction in power. So what we're going to simply do is this. We're going to bring down this power. For example, if you have y equals to x raised to the power of n, what you do is this. You will do the y, that's the y dx based on what is here. So you have y, you have x. So the y dx, the y dx is equal to, you bring down this power, n times x, and then reduce the power by 1. So your answer is going to be the y dx is equal to nx, n raised to the power of minus 1. This is what you have. So this is the idea of differentiation. Now, using this, let's look at this question. You have y, you have x. And also know that the differentiation of a constant is 0. So we have here, we have dy dx. So we're going to have dy dx is equal to, let me write it properly, dy dx is equal to, we bring down this power, multiplying this coefficient of 6 here. So 2 times 6x, then we reduce the power by 1, minus differentiation of a constant is 0. So we have dy dx is equal to 6 times 2. We have 12. 12x, 2 minus 1 is 1. So we don't need to write 1 raised to the power of x raised to the power of 1, because x raised to the power of 1 is the same thing as just x. So minus 0, 0. So this is the answer to this question. Now let's look at this other one. Let's look at b. Let's look at b. We have b is, you have y and x, so you're differentiating y with respect to x, the y dx rather. So we have dy, we have dy dx, dy dx is equal to, we bring down this 3, the coefficient that is here is 1, so 3 times, just like, let's have x, the coefficient here is 1, so we can see say x, 1x, 3 times x, reduce the power by 1, plus we bring down this 2 to multiply this 4. So 2 times 4 x 2 minus 1. And then the same thing here, plus the power here is 1. So 1 times x. Reduce the power of 1 here. The x here is 1. So 1 minus 1. And then minus the constant here. We say differentiation of a constant is 0. So we have dy over dx is equal to 3 times x is 3x. 3 minus 1 is 2, plus 2 times 4 is 8x, plus 1 times x is just x. 1 times x is, let's have 1 times x is x. X raised to the power of 1 is, 1 times x is x, so let's have it like this. X raised to the power of 0. 1 times x is x. 1 minus 1 is 0, minus 0. So we have dy over dx is equal to 3x squared plus 8x. X raised to the power of 0 is 1. That's in indices. Anything raised to the power of 0 is 1. So 1 is 0, no need of writing. So this is the solution to this question. Now let's look at the last one. Now, this question is simply, the interpretation of this is the same thing as 4 times 1 over x squared. Now this is the interpretation of 4 over x squared. So if you understand it like this is also the same thing as 4 times x raised to the power of minus 2. 4, this is the 4 here, and 1 over x is the same thing as x minus 1. So since we have 2 here, 1 over x squared is the same thing as x minus 2. So what you do, we go ahead to differentiate. So dy dx is equal to, we bring down this power, minus 2 times 4 x minus 2 times 4 Let's do gradually. Minus 2 times 4 times x raised to the power of minus 2 minus 1. So half dy dx is equal to minus 2 times 4 is minus 8x minus 2 minus 1 is minus 3. So we can have our answer as dy dx is equal to minus 8 times the same thing as x raised to the power of minus 3, same thing as 1 over x raised to the power of 3. So we can simply say dy dx is the same thing as minus 8 over x cubed. This is the solution to this question. So if you look at this, this is quite very simple. Now we're going to have this as a series. We're going to look at differentiation by first principle. We'll look at everything about differentiation as far as we can go. So thank you for watching. Do not forget to like, to share, and to subscribe for more videos. Thank you.